Hello, it's Doug from Emerald Hill Skies. I'd like to welcome you to tonight's live stream. We're continuing on our journey through Stephen James O'Meara's list called Hidden Treasures. And we've got the book here, we've got the list ready to roll, and we're so glad you can join us tonight. We're looking at a pretty good sky tonight. You can see the RASA there on the left, the other direction. And we're already imaging NGC 6819. This is the part of the sky we're looking at there. Perhaps you can make out a few of the constellations. Just in case, why don't we show you this kind of planetarium software, Stellarium. And you know, I'm still new at this. We did get our photorealistic horizon made. So now we're looking at trees and the top of our own observatory there. If you notice, our observatory looks like that, and you can see the roof of it right there. As soon as this, there you go, you can see the roof rolled off. Well, now you are looking at a photorealistic image down here at the bottom, and then we've also tried our best to shoot the points of the horizon, and we left a little bit of margin here so we can kind of see when stars are about to rise. Like Arcturus is just now raising up above the horizon, above these trees. We left a little bit of margin there so we could see when stars are rising. So you can see our compass points northwest and west, so we're pretty much looking at northwest, and we're almost up to the meridian here. See our RASA 11 there, and we're at a very beautiful part of the sky. You can see a lot of stars. Let's go to the live view. Here's the live view right here. We have about 7 minutes on this object. This is NGC 6819, and in the Hidden Treasures list, it's Object 98. Stephen James O'Meara called it his Object 98 in his list. So let's just look and see what he said about the Foxhead cluster or octopus cluster. While that's live stacking, let me see if I can get you guys on my monitor here so I can see if you're there. And I also wanted to hear, looks like the audio is good. Mike, good to have you aboard. Sorry you didn't get any rain from Ian. And Karen Blackwood, I don't know if you're still there, but good to have you aboard too, Karen. This is in the constellation Cygnus, and look what a rich star field that is. I mean, we're talking about thousands and thousands and thousands of stars, aren't we? It's a little and lonely open cluster located near the galactic plane. That's why there's so many stars there, huh? In the vast Cygnus Milky Way. If that sounds like a paradox, it isn't. Not every object in the Milky Way stands out like a bursting firecracker. The fact is, NGC 6819 is just far enough away from the mainstream of the celestial Mardi Gras, parading through the long axis of the Northern Cross, that it is as inconspicuous as a butterfly fluttering in a field near a busy highway. And he writes, it has long been wondered how so bright and tight an object escaped the gaze of William Herschel in his grand survey of the heavens. But it didn't. Thanks to research done by Michael Hoskin and Owen Gingrich, we find that William's sister, Caroline, actually discovered this cluster on May 12th, 1784. And he goes on and tells a little bit more of the history of it. You can see that it's a beautiful, tight little open cluster there. And it's a little bit hard to find if you don't have a go-to computer-driven scope like we have. It's a hidden treasure in a very lonely part of Cygnus. But if you know exactly where to look, it looks like a condensed globe of starlight, like a globular cluster almost. Yep, I would agree. So it is no surprise that Lund would have mistaken it for one of those more distant and older objects. Praetorius, good to have you here. Oh my goodness, it's Carlton! Welcome, Praetorius. So glad you're on board, Carlton. I've just been hoping that you'd join us sometime. I'm so glad you're here. So we're reading about Hidden Treasure 98. It's NGC 6819. It's a mini cluster, you might say. And I don't know how many members this might have. Somebody take a guess there in the middle. How many members, how many star members do you think it might have there? It's a beautiful cluster, no matter how you slice it. But it's so busy, such a busy part of the Milky Way that wow, it's like a bunch of Christmas lights on a bed of Christmas lights, isn't it? So let's do an observation over here, NGC 6819. Like usual, we'll have to start up our observation here. Add observation. Why is that? No, here we go. And we're going to start it up here, and we're going to say 10 to 10:03, and we're going to say maybe go till, give us plenty of time. We'll say till 1 a.m. We shouldn't last that long, but we'll just give ourselves plenty of time and try to get the A and AM. There we go. And in our notes, we'll just say, looks like a bundle of Christmas lights on a bed of Christmas lights. Tons of members of the Milky Way. Hard to count the members in this cluster, which is which, right? Dane, it's good to have you aboard. Can we zoom in? We sure can. Thanks for asking, Mike. Let's see. Wow, that's the core right there. This is Hidden Treasure 98, NGC 6819. It didn't take my notes for some reason, did it? We've got the right. Tons of Christmas lights on a bed of Christmas lights. See if it saves them this time. There we go. Now we're cooking. Sorry I haven't been able to join your live streams for a few weeks. No, it's good to have you here. And Blade Boy, good to have you as well. All right, well, let's head to the next object, and we've got this sequence that hopefully will take us to the next object. Let's go back and pick up this Hidden Treasure 102, which is a dark nebula. It's called the Northern Coal Sack. And we'll first show it on the chart, and then we'll also slew to it. And we'll let you see the scope as it slews there. The Northern Coal Sack. This is Barn 348. Barnard is what I think this stands for. Barnard 348. Yeah, it did look too blue, didn't it? NGC 6819 contains roughly 24 stars of magnitude 10 to 12, many more lower magnitude members. Stu, it's good to have you back. We missed you on that first observation. Appreciate that. We are still slewing our way over to Barnard 348. Let's go down here in our screen, and now we no longer have to see, how do we do? Here we go. Barnard 348, the Northern Coal Sack, a dark nebula. Okay, and we're saying the mount has settled long enough. I didn't really like our color balance on that first object either, Stu, so we'll work a little bit far. We got about a 50% moon tonight, and that might have been messing with our color balance a little bit. So we're looking for a dark nebula here. You guys know dark nebulae, they basically, it's like a patch of sky where there's not very much there. And that's because the dark matter is obscuring what we would otherwise have seen from the stars that lie behind this dust or appearance of matter that we really don't understand much. What is dark matter? I mean, it's kind of like antimatter or maybe gases and dust. So we're now starting to image this at 20 seconds, and we're using a gain of 100. So we'll pick up our first image here in a minute of this part of the sky, 20 seconds gain of 100 in just a moment, and we'll try to figure out what is this dark matter in the middle. You can see our red is dialed up way too high. I don't know why we're having so many reds, but that's why I got that other cluster too blue, I think, because I got a little bit carried away with dialing the reds down. Let's go over in our planetarium software and see what this looks like. So let's see. We should be, this is where we should be. Those are the coordinates, but for some reason this Barnard dark matter patch is not mentioned here. Let's try to search for it. Barnard 348. We could try using the let's see, Barnard. I wonder if it uses 348. No. Barn 348. Barn 348. Nope, it doesn't find. Oh, did it find it? Nope. Let's search under the name Northern Coal Sack. Aha! We've got it here. Get to the right place, and boy, it's just not readily apparent. But I guess it's because it's dark. So that's what we're looking at right now. Let's go back to our live view. So this is live view from our RASA 11. And I'll tell you what, let's do opaque matter. Yeah, opaque matter is better said, Mike. Let's look this up. This is object 102 in O'Meara's list and his hidden treasures. And let's see if we can read something about this. He's got several pages. It's the Northern Coal Sack, Dark Nebula in Cygnus. I wish I still had it. One of the star charts I used in the early 1960s to learn the sky. On it was an object that both intrigued and mystified me. It's called the Northern Coal Sack. It relies on the Cygnus Milky Way. But I wonder how many amateurs are aware of it today. For some reason, the Northern Coal Sack, at least in name, has been banished from almost all of today's popular star charts and atlases. And sure enough, it's banished from our planetarium software, Stellarium. The reason may be that confusion abounds over the Northern Coal Sack's precise identity and location. Actually, I guess we finally found it by using Northern Coal Sack. Part of the problem may be that any dark nebula visible to the naked eye was at one time called a coal sack. If you're wondering where this dark opening might be, do not fear. Its position has been dutifully recorded by several astronomy popularizers over the last century and more. We've got about 3 minutes imaging it so far. Right there in the middle, I guess, is where it is. He tells the history of people identifying it. It's a bit fuzzy of late. And it says the one between Alpha, Gamma, and Epsilon, Cygnus, carries the name Northern Coal Sack. He says it's been misidentified as Barnard 348 and Barnard 349. And he prefers Barnard 348. It's an object that's been known as a naked eye object since antiquity. How about that? And then he gives the history of all that. I've always been fond of the Northern Coal Sack. It epitomizes the great unknown. When I looked into its depths as a child, it caused my mind to stir, to awaken to a sad reality. There are things in this universe not meant for human eyes to see. It created a sense of helplessness, knowing that I could never peek behind the veil. it's a window of absolute night. Let's zoom in on it just a little more here. Look at that. I guess it's because it's black here, huh? A little bit odd, isn't it? Looks kind of dead in the center. Yeah, exactly. Well said, Playboy. Let's go back to our planetarium software again, and let's see what it sees. Nothing. Are we sure that we're looking at the northern Coalsack show chart? Yeah. Oh, it moved on us. This is better. Yeah. Now you can see this kind of T here that we're seeing. I wonder if our orientation, we've just been working with this new planetarium software. I wonder if our orientation is a bit flipped. I can't tell yet, but before this night is over, no, maybe it's right. Look at that river there of blackness. How about that? Who would have thought that one of the things we'd be trying to see tonight is something we can't see, right? I never thought about this before. It's contrasted with the southern Coalsack. It's a true hidden treasure. It's been overshadowed by the North American Nebula, which is ironic because the dark regions just west of North America and Pelican Nebula form the northern Coalsack's eastern border. Many ancient cultures saw creatures in the dark nebula. They saw it as something dark with wings. They drew it on cave walls. It's a wide ink spot. A negative imprint of a pirate's black flag with the one with the grinning skull and crossbones, the infamous Jolly Roger. Can you see those features with the naked eye? Boy, I don't know if I see that or not. Stu, you got anything else on this? I'm kind of reaching here. We'll do an observation on it the best we can, but okay, so we're basically looking at what we're not seeing. It's kind of like, what would it be called? A figure of an airplane in inky black with just a few pinpricks of starlight. If you look really close, there are just a few pinpricks of starlight here shining through, but can you see? It's almost an X shape, isn't it? Almost an X. What do you guys think? You see the skull? Boy, I don't know if I do or not, Mike. You have a little more imagination than I do. Mike sees a connect the dots skull, like an ink blot test. All right, well, that's 7 minutes, so let's push on. The Northern Cross. This is object 102. All right, so we're going to run this, refresh this list again, and let's head over to NGC 7027. So we'll show chart, I should say next target, and then we'll slew to it. And the next object is NGC 7027. Can I still change that here? Rats, I guess I can't, unless it's here. No, I took it away. Well, that's a shame. I'll have to work on that again so I can change that. NGC 7027. 7027. And I guess we've stopped slewing. NGC 7027 is object 104. on O'Meara's list. And let's see what we've got here. We're right on NGC 7027. Look at that. We can turn this. Well, I like that. That's a new feature, isn't it? Wow, if I hold down the control key, we can rotate this. I love that. All right, so we should be seeing a little bit of this object. What is this object? This is that's the North American Nebula. Should be seeing a little bit of the North American Nebula in this shot. But NGC 7027 is a planetary nebula. Let's go back to the live view, and I'll go down here in the dark in our title, and I'll change this to NGC 7027, the green rectangle. Is that what it's called? And this is X104. 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 Otherwise known as NGC 7027, the green rectangle. So that's the North American Nebula there, isn't it? Wow, and we're zoomed out as... Oh! Is that the planetary nebula right there in the middle? Let's bring our reds down because they're just kind of overshadowing everything. Let's try to situate our black line, maybe give ourselves a little bit less mids. Good evening from Arizona, Azray. Good to have you know. NGC 7027, also known as the Jewel Bug Nebula, is a very young and dense planetary nebula located around 3,000 light years from Earth, Stu says. Thank you very much, Stu. I think we're seeing it right there in the middle. So let's zoom in. And I just want to point out that it looks like the North American Nebula is up here on the upper left side, which is where it should be. So I think we are correct with our planetarium software. Look how this planetary nebula is just here on the outskirts of the North American Nebula. This is our planetarium software. This is the live view. So let's zoom in here. That's about the limit of our optical view. Optical zoom. It's very bright, isn't it? Yeah. Very dense. I don't know if we're going to see a central star in this. Maybe can't tell what the red should be like because of all the North American Nebula mixing in there. Let's check out in O'Meara's book. This should be X104. Let's see what O'Meara says about object 104 and see if he was able to see the central star with his 4-inch. No, he wasn't. It's one of the brightest, smallest, most unusual, and arguably the most fascinating planetary nebula in the night sky, he says. It is hands down the most extensively studied, both observationally and theoretically. Then he tells all the different studies that are being done of this, a lot of articles, tons of different papers, and comparing it to other things. He says the gas in the circumstellar envelope is mostly made up of simple molecules, such as molecular hydrogen and carbon monoxide, combined with several other gases such as cyanide, sodium chloride, and possible water vapor. Stu says the white dwarf at the center is believed to have a mass approximately 0.7 times the mass of the sun and is radiating at 77 times the sun's luminosity. So it's only 3/4 as big as the sun, but is 7,700 times brighter. That's interesting, Stu. Complex hydrocarbon molecules are also known to be present in the circumstellar envelopes. The material cast off during this phase of stellar evolution includes a large abundance of the key elements to the origin of terrestrial life: carbon, nitrogen, and oxygen, parent key origins. He says, he talks about the masses of the sun. It must have descended from a star with an initial mass of at least 4 solar masses. He peered through an eyepiece, and he listened to another guy describe it. He was soon swimming in a visual mire. The swollen disk was not so much a visual wonder. It just looks like a planet, doesn't it? At least not at the time. But one with a secret and seductive invisible nature. How does he think of these phrases? Now when I look at NGC 7027, I have an even greater appreciation for the significance. It's caught at a special time to study. It's a tiny marvel. And he drew it in his, he sketched it. And I'll show you his sketch here. There's the sketch that he drew. So he's seeing some hollowed out places with his keen-eyed visual study. I don't know. I'll tell you what we'll do. Let's zoom in with our digital zoom now and see if we can see some of those hollowed out places. Maybe just a tiny bit, but we're not. We're seeing it as a planetary disk, aren't we? A lot of Stephen O'Meara quoted on the wiki page. How about that? Okay, so we're going to do the observation here. And we're going to say X104 looked like a planet to us, indeed. We were only barely able to see a bit less brightness in the central core, but we couldn't make out the central star. Maybe because it was shining too brightly. O'Meara says it's one of the most studied planetary nebulae. If Carlton's still with us, he'll spot the way I changed that Latin to plural, I bet. Stu said it had 0.7 times the mass of the sun, but was 7,700 times brighter. That's just really wild, isn't it? Okay, say goodbye to 104. I'm going to run this refresh here. We try to stay under 7 minutes if we can. So we're going to move on. The next object that we can see here, it looks like it's the open cluster of 101. It's NGC 6940. NGC 6940. NGC 6940. Boy, our scope is bending over. Look how the weights are up with the weights to the east and the scope is to the west. This object is almost straight up. It's 80 degrees right now. And you can see how we'll have to watch it closely so that our scope doesn't bend over backwards, so to speak. Okay, so this is NGC 6940. NGC 6940. And change back to the screen here. This is object 10. I'm going to move this over so I can see that. This is object 101. Oh yeah, there it is in the middle. This is X101. O'Meara uses the name X for his catalog. 101, it's called also Colander 424. You can see our sky cam view there. That's the moon shining brightly over there. Let's go back to our planetarium software. There's the NGC 6940. You can see this is the meridian, and we're getting ever so close to it. (6940). Wow, so we don't want to hit that meridian, do we? Oh wow, we're still slewing, huh? Do you think we did a meridian flip? We did. We had to do a meridian flip because it was, I see, it was 80 degrees on the opposite side of the meridian. So our scope was smart enough not to bend over backwards and break its back. And so what it did is it automatically initiated a meridian flip. So what we're going to do is we're going to stop our live stacking because our scope didn't talk to our imaging software, SharpCap, when it decided to do its meridian flip. And I'm going to go back to a little bit faster exposure here and do one more plate solve just because we had to change 180 degrees around the sky. You can see the moon's kind of on a different side of the scope now. Now, to get an idea of the side of the sky that we're on, we can go back to our planetarium software and we can look and see that this is the southern part of the sky. That's the west. You can see we just passed the meridian, which is that imaginary line like that divides the east from the west. So we just passed that. Let's see. NGC 6940. Let's go back and see how we're doing. Yeah, I think we've grabbed it again. I think I have a little sequence that just prepares us for imaging, and it doesn't do the plate solving. Oh my goodness, what happened? Oh, that was the clearing the live stack from the last live stack. Okay, so Stu says it has about has hundreds of members. It's quite scattered. And it's in between its members are also visible. There are some field stars in there. Don's with us. Don's saying if you like content like this, be sure and hit a thumbs up. And Stu came back and said it's 1 billion years old. Wow. 1 billion years old. Look how high our reds are again. This is just weird tonight. Guess that must be the moonlight. So we'll scoot our hundreds of members. How about that? Now we're back now at just 50%, but look how much of the sky this cluster takes up. It's so massive. Look at that one red giant looks like there. Kind of zoom in on him. See that red giant right in the middle? He kind of stands out, doesn't he? So again, this is NGC 6940 X101. Let's see what O'Meara says about him. Oh, thanks. Appreciate it, Stu. You are so kind. Yep, thanks, Mike. You guys are great to watch out for us. Okay, somebody report the guy, please. Why do people do that? This is not a porn site. NASA and SpaceX are in negotiation to reboost the orbit of Hubble and maybe serve as a 2, hoping to extend its life past 2050. Well, that's cool. All right, so this is X101, Hidden Treasure 101, NGC 6940. It's the Mothra cluster, M-O-T-H-R-A, Mothra cluster in Vulpecula. Very rich cluster of pretty small scattered stars. That's what Herschel wrote. NGC says, cluster very bright, very large, very rich, considerably compressed, stars pretty. I would agree. When you hear deep sky observers mention the constellation Vulpecula, the little fox, it's usually in connection with either the spectacular planetary nebula M27 or the coat hanger asterism, or the mysterious open cluster NGC 6885. But it's also home to another visual gem, NGC 6940. It's a most abundant star cluster in the southern branch of the Milky Way, bordering the Great Rift. That sounds like something in Star Trek, doesn't it? But he says it's largely ignored, and you know, that's what the Hidden Treasures is all about, finding objects that are largely ignored. You'll find it lost in the void between the southern wingtip of Cygnus and the little fox's hindquarters. Let's go back real quick to our planetarium software, and let's back off. And let's put the constellation shapes and names on here. So here's Cygnus the Swan, and here's Vulpecula. So you can see how this object is indeed lost between the swan's wing and this Vulpecula. It is kind of a busy part of the Milky Way, but this cluster stands out, huh? He talks about the history of some of the observing of it. He says it's easy to see in 7x50 binoculars. It's an elliptical swarm of dim suns shining with a total light of a 6 magnitude star. The brightest members of NGC 6940 shine at 11th magnitude, but altogether they make a total magnitude of 6 magnitude, which is the limit of naked eye visibility. Some brighter field stars are superimposed on the cluster, that are not a part of it. In my antique telescope, the cluster looks like a dwarf elliptical galaxy. Elongated. Open clusters are only weakly held together. And in other words, it's very weak power that holds them together. And they're fated to disperse over time. The largest open clusters tend to have ages around 5 billion. But Stu said this one was a billion years old, I believe. And it's included in the Herschel 400 catalog. I don't know if we've seen it either. I don't think so, because surely it would have not shown up in our observations here. It's quite stunning in a small telescope under a dark sky. Highly elliptical body of shimmering lights with many star clumps that give off a rich, mottled glow. A bright pair of stars lies just west of the cluster's heart. 720 million. Is that the distance, light years? Stu? The brightest member is the semi-regular variable star FG Vulpecula, which varies in brightness from 9 to 9.5 every 80 days. Vulpecula has a warm orange hue. So that star that we saw is a variable with a warm orange hue. Look at it right there, how that stands out. That bright orange star. That's the one he's talking about. It changes every 80 days. The rest of the cluster stars scattered across the field like diamond dust in a strong and erratic wind. Indeed, the cluster's core is splintered into 3 highly elongated groups. You think so, huh, Stephen? As if carried aloft by a jet stream. We're on 6 minutes, so we don't have much left on this time. It's rich, having some 170 members against a Milky Way background, so it's almost exhausting to observe it. 720 million years old. So much to imagine. Increase the magnification and more background stars can be seen more and more pairings and groupings and lots of doubles and triplets and quintuplets. Oh. 2 looping arcs like insect wings. One wing lies to the northeast, the other to the southwest. A forked string of stars flaring to the northwest forms the insect's tail. You can tell that that's why he said it looked like a giant moth. So he gave it the name, the Mothra cluster. So again, he says it's 170 members. Here we go, adding the observation. 170 members. O'Meara called it the Mothra cluster because he saw a moth in it. Stu said it was 720 million years old, around 170 members. Good to have you aboard, Kimberly from Florida. Red giant FG Vulpecula stood out from our first glance. Awesome. All right, so we're going to say goodbye now to X101 NGC 6940. I didn't have the NGC number correct, did I, on that title, did I? NGC 6940. Sorry about that. I'll try to be a little better on that. But the X101 I think was correct. It's gone now from the observing list. All right, let's head to the next object. Next target. Notice how now I've got in the sequence, it automatically kicks us back to a full frame view on our sensor. And I've just discovered that programming module, so it kicks us back to that auto sensor. I'm really glad. Okay, so the object we're going to next, it looks like, is X103, another planetary nebula. And we're going to salute to it now. So there goes the scope to X103. This is NGC 7008. NGC 7008. I don't like it that I can't change the title anymore. I gotta bring back the title scene. I wonder if I can do that on the fly while you guys are watching that scope slew. Let me try. Title, and we're gonna make it a scene. And I'm gonna add the existing. I see. We've taken away that scene altogether. Yeah, that's going to make it hard to do. Rats. Okay, so it looks like the mount has settled. We're going to give it the OK here. And now we're going to change this title to X103. This is NGC 7008, a planetary nebula in Cygnus. It's also known as the Fetus Nebula. How about that? Looks like we had to slew a little bit. And that was good because our program was still waiting for the telescope to settle. So that looks like it's working. It waits for 25 seconds after I say that I thought it had settled, but it hadn't really settled. So then you notice it comes up for a moment and it shows us the last live stack because that's still held in RAM. And then the program that we've sequenced here, it automatically clears it, and then it starts imaging at 20 seconds. So all this is automated now. I like it. It's called the Fetus Nebula, Stu says. I'm going to go ahead and, oh my goodness, look at that. How interesting is that? I'm going to open up a observation on this so we can already jot down some of these things that Stu is saying. NGC 7008 is also known as the Fetus Nebula, a planetary nebula with a diameter of around 1 light year. That seems big. 2,800 light years away. That's not bad. Hey, Papa Tech, good to have you aboard. Papa Tech, are you okay after Ian hit you guys down there? Yeah, Stu's already saying he hopes you're doing okay. Well, as you can see, our reds are really high tonight. I'm not sure why they're doing this. Maybe it's moonlight, because we do have a 50% moon, but every automated color balance, these reds are absolutely astoundingly bright. I'm going to bring them down manually so they're just barely visible, and then we're going to bring our black point over to right there in the blues maybe, so we make the sky a little blacker, then bring up those mids a little more to kick up this planetary nebula as much as we can. Boy, that's awesome. We are able to get it pretty high up there before the colors start choking us out. Now, let's see if we can move into the limit first of our optical zoom and hang out there for a minute. I can see why it's called the Fetus Nebula, can't you? Take a look at it there. Let's look at it in our planetarium software. Notice rats. This is not good. So what I'm going to do is I'm going to copy this. Oh, there goes a little satellite. I'm going to copy this to the clipboard, and I cancel out of this observation, and we're going to say show chart. Make sure we're synced here. There we are. Now let's whoop, zoom in a little more here. Let me do that show chart again. And then what I'll do is I'll click on the object. There we go, the Fetus Nebula. Boy, it agrees with you, Stu. And there we go. You can see like why they called it a fetus, can't you? Let's get an idea of where we're looking here, where we are in the night sky. Notice our new horizon, which I've got matched with our trees, and then I've also got a photorealistic horizon here. This is the building I'm sitting in right now, captured as a photorealistic horizon. You can see we're almost due north here. Look, that's the meridian, and that's the north point. And once again, I think I can hit, yeah, that'll line up our scope with it. Now let's go back to our live view, and let's zoom in a little bit with our, let's bring those mids down just a little bit. Keep those blues from hopping out of the background there if we can. There we go. That's about 100, that's 200% up in the digital zoom. Papa Tech says there was some flooding and some trees down and some lost screens. Kimberly's down there too. Dark Matter, good to have you aboard. Yes, Dark Matter, we are on board. I wonder if I can remove those. Look, I can. Remove. That's just a feeling of power, isn't it? Look at that. You can just remove those intrusive messages. Flooding and some trees down, lost screens, power was out, but they're doing the best they can, so better than Southwest Florida. Don says, I knew if I came here tonight I would find a date. You're talking about a dating site. Dawn, that's hilarious. We've removed those, Dawn, so remove those from your mind. I see nothing. Remember those old reruns of Hogan's Heroes? Pier-Tech says 95 sustained winds here for almost all night. That's a lot of wind. Stu says, I'm looking for a young single planetary nebula in my area. Nice. Dark Meta, Dougie Doug. Don says, must be 750,000 years old and love travel. That's hilarious. How old is this planetary nebula again? And how did it get shaped like a fetus? We've already got 5 minutes on this, so we must hurry to X103. Does Stephen James O'Meara tell us why it's shaped like a fetus? That's the question. He calls it the Coat Button Nebula also. The Coat Button Nebula. It's a bright, peculiar planetary nebula, all but lost another coal sack of Cygnus. William Herschel found the object during a survey sweep in 1787, but he classified it as a bright nebula. He must have found it curious because he returned to it 2 more times. And then he tells about other observers, other observatories. The stars superimposed on the nebula are indeed very interesting features. One of them is, in fact, the 13th magnitude central star. Can you make it out? Can you see it in the middle there? It appears slightly offset from the center to the west. Spectral observations of the other stars reveal them to be condensations expanding with the surrounding shells. Wow, so they're not stars? One of them, called Condensation A, is a star-like knot 5 arcseconds wide, about 22 arcseconds northwest of the central star. Wow, I see it. So that's Condensation A right here. I wonder if that's in our... Whoops, we've lost... There we go. Now let's go back. They classified that as a star. And that is a star. I'm afraid that Stellarium classifies all these as stars, apparently. How interesting that it's just condensation. Go back to our live view. We're at 8 minutes, rats. I'm off time budget, but it's so interesting, isn't it? The longer I stare, the more fascinating it becomes. The nebula appears mottled. It scintillates like sunlight on water and beckons for more power. Dark Meta to Anger Feminists. Kimberly says, that's beautiful. You're right, Kimberly. It's an elliptical mass, pinched in the middle. Yep. It's oriented northeast to southwest and has 2 bright bow tie-like knots at the antennae. At the antennae. I see those knots. Let's go in a little bit more digitally. Maybe you can see them. He's talking about these little knots here. Fascinating, isn't it? He says the shell is dappled with starlight or glowing beads of light that form a misshapen boxy annulus. Given the visual impression, it's understandable as to why William Herschel classified this irregular object as a bright nebula rather than a planetary nebula, but modern images tell a different story. The object is clearly a bright ellipse of light. Wow. It's a fan shape spreading out from the... Oh, I see. It was made by a double central star, and that's why it's warped, because it's a planetary nebula from a double star. The name, the Fetus Nebula, was by Eric Honeycutt in 2001 in an issue of Amateur Astronomy. In the abdomen region, it's very large. He says it looks like 2 buttonholes through which one needles the thread. I don't know about that. I kind of like the Fetus Nebula name better. Okay, here we go. We're going to add observation. We're going to say Fetus Nebula looked like a fetus to us. Born from a from a pair of central stars. It's headed right at us, Stu says, at 75.7 kilometers per second. Don says, I keep seeing ads for adult dating sites. I am so sorry, Don. I hope those disappear. So odd. All right, that's the end. We've got to shove on now. Next target. Now we're going to sort our list again, and we're going to head over to OCL 1675. It's object 105 on Omira's list. Object 105, X105, OCL 1675. OCL 1675. And we'll wait till the mount settles, and while it's working there, we'll go find this in our star chart, show chart. Is that it? Surely not. Open cluster, OCL 1675. I wonder if it's not in the index that way. Look how there's another object superimposed here. LBN 455. I'm going to do this little tagline at the bottom. X105, and it's supposed to be OCL 1675, an open cluster in Cepheid. I wonder if it's called IC1396. No, that's the H3 region. So what is the open cluster called? And it's right here by LBN 455. What is the cluster called? Anybody got this? I see them. Don says, okay, annoying. Yeah, we're being haunted, aren't we? Remove. Remove. Whoever this is, if you can hear us, maybe this is done by bots, so they're not even hearing us, so it's kind of, you know, annoying, isn't it? We're kind of being spammed here. Remove. 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 Okay. Yeah, I reported them as well. Deleted the messages and reported them. All right, we've got to figure out how Stellarium can look this item up. Let's go to the index. Whoops. Let's go to the index, and let's look for Misty Clover. That's not in there. Didn't find that. Didn't find it in Simbad. Let's look for OCL 1675. Let's leave a space between the OCL. Didn't find that either. So now what? Trumpler maybe? Trumpler 37? Look at those satellites scooting by. Trumpler, oh, TR, there we go, 37. Now we've got it. Yep. It shows up as Trumpler 37 in Stellarium. So we're in the right place, huh? But look how this IC1396. You know what? That's the Elephant Trunk Nebula. Right there is the Elephant Trunk. So this is Trumpler 37. Dark Meta says, hey man, Frank Rossetti, welcome. So glad you're here, Frank. It's been forever since we talked. Frank, I've got to tell you that you know, I hope, the story. I think you already know that the folks on Cloudy Nights finally just, they did away with my credential there, and they thought I was trying to market something, but you know, I really wasn't. I was just trying to market the sky, but because I was doing so much promotion or something, I think I just got on their nerves, and they threw me off Cloudy Nights. So I am no longer there. I think I probably already told you that, Frank. Azray. Okay, so we're doing a plate solve now, and we're waiting till the scope settles. That's a pretty good view of the cluster, Trumpler 37, I believe. And now we've started with live stacking. Frank says it has been a while. Frank's a fellow electronically assisted astronomer from up in Schenectady, New York. Frank has a long focal length scope and also a wide view scope, and has helped a lot in some of our observations, helped me get started. I know. What do you think of that, Dark Meta? Banned me from it. Now, before you think that that red is overdone, that red is real. Let's go back to our star chart here. Look at that red. It's what you might call the Elephant Trunk Nebula. The Elephant Trunk Nebula. It's IC1396. But we're finding out tonight the name of the cluster that is lighting up that nebula. So we're kind of learning some things here. The cluster is called Trumpler 37, otherwise known as the Misty Clover Cluster. And now we know that Stephen James O'Meara has called it X105 in his list of hidden treasures. He also says it's known as OCL 1675. So this red that you're seeing here is actually real. And we're going to let that come in. This is not any kind of an aberration of moonlight tonight. We're going to actually just accentuate that red a little bit. And then these stars that you see here are the cluster stars. I know, I've just done this, Frank. I've just come over to Stellarium. You know, I cataloged about 5 things that started annoying me a lot in Starry Nights, and I started in January, bubbling them up on the community bulletin board and asking SimCur to give them some attention. Every month I would go back and I would bubble them up again. The observation applet had a glitch. About 1 out of every 5 times I started an observation, it wouldn't let me enter maybe more than 2 or 3 characters. The observed column had a glitch. The telescope connection had a glitch that caused the whole thing to crash about 1 out of 10 times, and I sent every report to them in the crash. I didn't like the fact that they weren't updating it at all, and I didn't like the fact that they let 9 months go by before they answered my complaint at the customer support site. So I listed these and I said to SimCur, I quit. I've been, I think, from what I can see on YouTube and the web, I think I've been your most the most active advocate you've had. And you've completely annoyed me now by these glitches that you said you would fix and haven't. I quit. And so I pulled all 15 videos I'd done that were tutorials about Starry Night. I pulled all of the advocacy I've done. I pulled it all down, and I started looking for another planetarium software. And you're right. Stellarium was the next best, prettiest. And it's actually better in the way it actually functions, as you already knew, Frank. And I've used Deep Sky Planner now for my recording of observations and for my actual planning, so I don't have to use Stellarium for the list of objects. And Stellarium's working great, though, for you know, a sky view of the actual night sky, the planetarium software portion. Now you can see up here the part of the object that gives this nebula its name. It looks like an elephant's trunk to some people. Now personally, I don't find that it looks like an elephant's trunk as much, but it's this portion right here. Let me zoom in on it a little bit, and you guys can see if you think it looks like an elephant's trunk. I guess you have to turn your head upside down, don't you? Now, this object shows up like a person's fingernails. They must have talked to Cloudy Night's moderators, making them some notoriety for yourself. I don't know if they did that or not. Look how this object has a look of like somebody scratched it with their fingernails. And I did some research on this. And you know, this object is known for stellar wind from some of these brighter stars like this one. And some people say that in some observation, you can actually see the hydrogen gas blowing across your view. And I hope I'm not imagining this. It really almost looks like that in this RASA 11-inch view. Remember using a RASA 11, and it's an 11-inch scope, and we're using a pretty sensitive camera. It's a ZWO ASI2600MC Pro in that Tele-Station 2 observatory that Pier-Tech made for us on that Pier-Tech adjustable mount. You can see the roll-off roof in this next slide right there, where the roof is rolled off tonight. And actually you can see the scope. It's 11 inches, and in this scope, for some reason, we can actually, I think, if I'm not mistaken, we can see the stellar wind is blowing this hydrogen across our view. Now maybe this is somehow just an aberration, but it is interesting that it shows up in this view for us. So that's the Elephant Trunk Nebula. But we're not really here to view the nebula. We're here to view the cluster, which are these stars that are lighting up the nebula. Let me just take a moment and remove these new dating site spamming entries. There's a dark nebula here. It is LBN 456. LBN 456. No, sorry, 455. LBN 455. And I'm fascinated by the fact that you can not only see the nebula over here, the Elephant Trunk Nebula, but also this dark portion here, which is LBN 455. But we're here to observe the cluster. We have 6 minutes. We've got to push on, but this is such an interesting object, isn't it? So, Trumpler 37. We found this cluster in Stellarium by searching for Trumpler 37. It is superimposed on IC1396, the Elephant Trunk Nebula, which steals the show. But this cluster is lighting up the nebula, making it beautiful for us in the night sky. Well, we're going to have to move on, guys. I'm so sorry. This is such an interesting object. I just really hate that we're not going to see. Let me move another couple of these. You know, I'm kind of almost encouraged that these bots are finding us and spamming us, because it means that it's noticing us. Never thought I'd feel lonely here, but there it is. Don, you're hilarious. Okay, the next object that we're looking at here is the open cluster NGC 7380. So let's slew to it. NGC 7380. NGC 7380. And let's go back to our live view now that the scope is settling. And let's make our tag correct. This is NGC 10, or it's X106. NGC 7380 and open cluster in Cepheid. It's also known as Colander 452. So we're going to show it on the chart. NGC 7380. Yep, the Wizard Nebula. But we're looking at the open cluster that is powering it. Look at that. So again, it's a case in which the nebula steals the show, but look at the cluster behind it. That's what Stephen James O'Meara is trying to get us to see. NGC 7380. It's the cluster associated with the nebulosity. How interesting. See, I would have never thought of this, because I always just think of the Wizard Nebula, and I go there to try to see that. But I don't think of observing the cluster of stars that are powering it. Again, we're observing the cluster of stars that power a hydrogen alpha region, the Wizard Nebula. Look at the stars, O'Meara is saying. And he's got a good point. We always just go look at the Wizard Nebula, don't we? Scammers unleash their bots on whatever streams are live by searching. Oh, dark matter, you burst my bubble. Don says, make sure you're hitting the thumbs up. Don, thanks for mentioning that. What Don is saying is that if you like content like this, if you hit the thumbs up, it helps it be found by others. And if you haven't subscribed and you like content like this, I hope you'll subscribe. Stu says, not if you use uBlock. How about that? Stu's got a solution for these spammers. Don says, I grew up with the ads on network television. I'll survive. Okay. Let's go now and look at the live view of this. Yep, sure enough, there it is. The reds are turned up way high. You can see that in our planetarium software. There is some nebulosity out here. There are some clouds here, but it doesn't have to be this high. So the planetarium software gives us a benchmark to be able to judge. Now this looks like a dark nebula here, doesn't it? To judge what we're seeing and keep it real. I'll pull this a little bit right there, but I'm going to put the reds back up because this is a hydrogen alpha region. So if we don't have the reds up some, we won't see the Wizard Nebula. Okay, so that's looking better. Got that background a little bit a little bit tempered now. So look at the cluster. Don't just get lost. Don't just get lost and look at the nebulosity. Also look at the cluster. That's just 2 minutes. Oh my goodness, these spammers. What in the world? I tell you what, they picked the wrong guy, didn't they? I am not about to participate in any of this shenanigans. Stu, what can you tell us about this cluster, NGC 7380? We've got 2 minutes on it. Let's look and see what Stephen James O'Meara says. It's NGC 106. He calls it Harry Potter and the Golden Snitch. Otherwise known as NGC 7380, an open cluster in Cepheus. It was a beautiful sight on the evening of September 18th. In a long and flowing evening dress, slipped by Caroline Herschel's open cluster. Oh, this cluster slipped by in Cepheus and gave it a kiss. It was a scene straight from Walter Hartwright's narrative. What in the world? Anyway, Caroline Herschel found this in 1787, and things were rather hectic. All of this history. We're still reading about the history. Okay, here we go. To Caroline and her brother William, NGC 7380 was merely a coarsely scattered cluster of stars. But what a marvel of nebulosity surrounds it. So O'Meara is pointing out that she saw the cluster, but not the nebulosity. NGC 7380 is situated about 4 degrees from the nucleus of the extensive Cepheus OB1 Association, an old star-forming region. 7380 has 125 members of ninth magnitude. Stu says Mount Lemmon photo is very red, Wise photo is very yellow, Hubble is purple. And Don says, and you'd see green. Stu says it's a complex located at a distance approximately 8,500 light years away. If you could see it through a telescope, Don says. Oh my goodness. How do I prevent these things from coming back? I hate it because they're just wasting our time. Maybe it is extremely difficult to observe visually, usually requiring very dark skies and an O3 filter. But thanks to electronically-assisted astronomy, we've dialed down the nebulosity a little bit so you can focus on the cluster. And there it is right there in the middle. It's a turbulent sea of pink gas clouds washed by waves of dark dust. Nice work, boss. LOL, Darknetta says. Color images of the region show turbulent sea of pink gas clouds washed by waves of dark dust. They're gone for me. We can make them a little more visible for you, Dark Meta, if you want to see them a little more. And let's zoom in a little more. And we can dial them up a little more if you want them. We can make them visible. That's a little bit too much dialing, isn't it? We need some more time. We're 6 minutes on this. But you're starting to make them out. But we're looking at the cluster. You'll probably need a moderator at some point, once he gets more famous, Stu says. Darkman, it's not that big of a deal, really, just annoying sometimes, yes. Radio observations reveal 2 components in this cloud, one in the northeast and one southwest. Oh my goodness, he writes pages about this. He starts talking about the stars and how they're different colors. Wow, now that's a trick. Your colors may vary. Various observers have reported seeing pale orange and blue, blazing yellow and bluish white, yellow, blue. There's all that nebulosity, a ghostly quality to it, a glow that differs ever so slightly. 50 stars pop out. The nebula is a hyperfine glow. The brightest section surrounds a triangular-shaped wedge of starlight. See the triangle shaped? Thunderstorm rolling overhead for Stu. It's a pretty area with lots of dark nebulosity. Most prominent dark feature is 30-minute long lane. That's the one we saw, I bet. As with IC 1396, the entire region is patchy with starlight. If I relax my gaze, I see a little dipper or a ladle comprised of the triangular wedge and a handle of stars to the east. Condensed patches of nebulosity around at least 4 stars. I know these nebulous glows are real because stars of similar magnitude near them do not share the glow. Furthermore, these patches coincide with dense nebulous regions as seen in long exposure photographs. Most prominent is a knot of nebulosity 5 minutes southeast of the double in the bright arc mentioned above. Yep. We're seeing those knots by dialing up the reds. Try using your imagination to see the brightest stars in the region. So he says 50 stars pop out. Depends on the quality and quantity of. Well, I've become a mod. I will rule with an iron fist. Okay, so we're going to say here the cluster would have been beautiful on its own. 50 members pop. Okay, so this is X106, NGC 7380. We are going to tune this black just a little better if we can. Let's give this a little more presence from the night sky. And then, that's probably realistic there. Let's save as scene. GC 7380. I think this might be our first image of the Wizard Nebula. And then we're out of here. Next target. See, we started at 9 o'clock, so we've got 40 minutes left, 38 actually. 100 million USD in cash on a table would be very hard to say no to. Just ask Congress. Oh, Dark Meadow was saying spammers were gone from my chat after you blocked them. Yes. All right. So the next target, let's do a refresh here, is 108, and it's in GC 7789. GC 7789. So let's slew to it. NGC 7789. The mount is settled. How fast can a system like this pick up something like the Dark Shark Nebula? Ricky, good to have you aboard. Well, I guess we will be starting live stacking there. Let's look and see what we're looking at. This is an open cluster. Look how interesting that's going to be. It almost looks like a globular cluster. How interesting. There's the RASA synchronizing with it. I love that, the fact that we can see it. While it's starting to live stack, let's go look at Baby Shark, the Dark Shark Nebula. Dark Shark Nebula. So we're going to just go to the index here and say Dark Shark Nebula. I would say it would be very quick, Ricky. We're kind of on a hunt here of these objects that Stephen James O'Meara has written about in his Hidden Treasures book. But let's make a note to do the Dark Shark Nebula later. Good to have you here, Ricky. Maybe we can do that at the very end. But you can see we have several objects still that we can go look at. Now let's go back to where we were, and we can do that in, by the way, that's where the Dark Shark Nebula is, and we'll try to go look at that later. Let's go back to this. We can do this in one click just by saying show chart and then hitting the space bar, right? I thought we could. Show chart. There we go. So this is 7789. I think we could image that pretty quickly. Boy, those reds are popping tonight, aren't they? You can see by this view, the red should not be that dominant. So something is odd. Something is amok. The reds, I think, are being affected by the moon, maybe. And our Celestron light pollution filter, perhaps. Boy, that is just a very dense open cluster. I mean, it's almost an oxymoron to say it's a dense open cluster, but it is not globular, but it is so dense, isn't it? Light pollution and moon glow together, Azray says. I think, Azray, it means a lot that you would help us see this. Now look at this star down here. Look at how that star is a red giant paired with this other one. And that shows us that our reds are in balance now. At least we can see them. Here's another red giant over here. But in this cluster, we're largely seeing a bluish, greenish look, which is in keeping with this view in our Stellarium planetarium software. 108, 7789. 108. $77.89. It's an open cluster in Cassiopeia. Cassiopeia. I hope I spelled that right. How embarrassing if I didn't. This is beautiful. You know, we can already save that exactly as seen and have something beautiful. X108. Let's just see briefly what Stephen James O'Meara says about this while I remove these pesky bot. Somebody invent something. I guess, Stu, you're saying that you've already got something. It started with the letter U and it was called U-block. 108. X108, Herschel's Spiral Cluster. The Crab Cluster, also known as the Screaming Skull Cluster. It's allurous, seductive, more so than an adult dating site. Don, you keep. It's basically one of the finest and rich and open star clusters in the sky, O'Meara says. One guy, Reverend T.W. Webb, said, beautiful, large, faint cloud of minute stars. John Herschel called it a most superb cluster. Caroline Herschel discovered it, 1783. And then they described it with poetry. It shines a magnitude of 6.6, lies at the limit of unaided vision, making it a great naked eye challenge on dark skies. he found a way to find it naked eye. O'Meara is really amazing, isn't he? With binoculars, 7x50s, it's as large as the full moon. It looks like a tailless comet. You know, you could really imagine that if you back off. Look how it would look like a tailless comet. And then when you see it in the planetarium software, look how that would look like a comet. Makes sense, doesn't it? Don, it's so nice of you to ask Ricky to hit like. Don, you're like the marketing specialist. Anyway, this star over here is the one that Stephen James O'Meara said. You look between this and that star and look halfway between, and he says that's how you find it with naked eye. He says it's a bit too large to make a decent magnitude estimate with binoculars. We're at 6 minutes, so we got to hustle. 580 stars. Of course, they're at magnitude 10, and the faintest hover magnitude 18. So let's remember that, guys. 580 stars between magnitude 10 and 18. He writes so much. Oh, he's saying there's some nebulosity between the 7th and the 9th magnitude stars. We've probably turned the nebulosity down because of our trying to get rid of the reds. Maybe over here? Kind of like the Pleiades has, maybe some blue. I don't know. I don't see the nebulosity yet, but we're just 7 minutes into this. Having said that, we're 7 minutes into this. Look at this row of 4 stars in a line. It just looks like one of those star trail satellite arrays, doesn't it? Man, that is a red star here, isn't it? That's as red of a red star as you've ever seen. And look, all these other stars are bluish, greenish, whatever, but look how red that one is. I'm supposed to be red-green colorblind, and I can see that. Don says, that's a lot of stars. Ricky hit like, thank you. Don says, yeah, about my marketing salary. The Milky Way surrounding it is equally impressive. Okay, so let's remember what he said. He says it's, how many stars did he say again? I've already forgotten. 580. 580 stars. So let's do our observation here. $580 members, some shining with bright orange and some nebulosity we thought we might barely make out, similar to that seen in the M45. One of the most beautiful open clusters, just faint to the naked eye. Mag 10 to Mag 19. Ricky, Baby Shark. Don, why did you have to get that song stuck in my head? Baby Shark. 580 stars, a lot of counting, Azray says. Azray says, I counted 581. Don, I want to know how you decided which ones were part of the cluster. Indeed, isn't that the truth? Let's do a picture of this one more time, because because this is just an amazing sight. And then we'll do our little sequence here to go on to the next target. And we've got 25 minutes left. We're not going to make it through all these. The next is 107. And it is also known as the Little Ladle. The Little Ladle. It's also known as well, it doesn't have an NGC number. So we're just going to call it Little Ladle. You could find out using the spectral shift, but I doubt he measured that. I want to know how he decided which ones are part of the... Oh, I see. You're saying, yeah, you could look at the spectral shift of the member stars because as the cluster traveled, they would all be traveling together. Good point. And let's go on and change our tag here. It's NGC, it's X107. The Little Ladle. An open cluster in Pisces. This cluster immediately doesn't stand out as much, does it? But we're not live stacking yet. Maybe it'll come out more because it's probably dim like the last one. 107 was his X number. He chose X because he said if these are hidden treasures, you could think of it as X marks the spot. Oh, wow. Hidden treasure 107, Omira 1. It's also known as Alessi J23407 plus 0757. He says it's just an asterism. Here we go again. Remove. 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 Okay. Did that get them all for now? The night sky is filled with hidden treasures. Let's dial down the reds. You can see the asterism right there in the middle. This is the asterism that he says he's going to call it Omira 1. I guess if you're this famous, you can name things like that, right? Stephen James Omira independently discovered it in January 2003. A celestial treasure does not have to be a galaxy, nebula, or cluster. It can be any wonder that sparks emotion or stirs the imagination. It can be as simple as a solitary star with an adorable hue, or a chance grouping of stars that form an attractive or bewitching pattern. The treasure's worth is a matter of personal appeal. Does it bring a smile to our face when we see it? Does it kindle even the smallest of flames in our hearts? The 107th treasure in this catalog may be one of those objects. You will have to judge. You might not have heard of it because its discovery is relatively new. But that's the purpose of this catalog, to introduce you to new wonders that will keep you company in the night. Here's the story behind my first encounter with the asterism I call the Little Ladle. Let me get my arrow out of there so you can see. The ladle. Can you make it out? Azray says, it does look like a ladle. Let me zoom in a little closer. We're just at 56% now. Let's go all the way to our optical limit here at 100%. See if you can see the little ladle. On the evening of January 20th, 2003, I was driving helter-skelter across Volcano, Hawaii. And by the way, our family did make a trip to Hawaii, and we did drive through the town of Volcano, and we did find out Stephen James O'Meara's address. We wrote him, and he answered us, and he told us his address, but he also said he wasn't going to be available. But we did drive by his house. And no, I'm not like a fanboy, but we did drive by Stephen James O'Meara's house near Volcano, Hawaii. He was looking for a clear spot between clouds to get a glimpse of Comet 2002 V1 NEAT, but the weather failed to cooperate. Giving up the chase, I turned off the Volcano Highway and started to return home. Suddenly, I saw a hole in the clouds to the west. Quickly, I pulled the car over, turned off the engine, grabbed my 7x50 binoculars from the passenger seat. I slipped outside and promptly found the 6th magnitude comet in the southeastern Pegasus near the Pisces border. Quickly but carefully, I scanned the region for comparison stars so I could estimate the comet's brightness. That's when I spied a large diffuse object, some 1.5 degrees south of the comet. It was a new object that looked like a comet with multiple nuclei strung out in a line. Suddenly I recalled the famous squashed comet that Carolyn Shoemaker discovered in 1993 while scanning photographic plates taken by her husband, Eugene, and David Levy. This comet, Shoemaker-Levy 9, had fragmented into more than 20 pieces before it ultimately smashed into Jupiter the following year. For a moment, I wondered if Comet 2002 had broken apart. Better yet, had I stumbled on a new comet, perhaps a faint one, that had flared in brightness as it split apart. I had witnessed several comets perform in this manner. The skies remain overcast. Oh wait, he says, before he could finish his thoughts, the clouds closed and I lost the stars. Fortunately, I had memorized the new object's position. Only Stephen James O'Meara would have done that. Without hesitation, I returned to the car, found a pen, and recorded the new object's position as best I could on a paper napkin. The skies remained overcast for 2 days. So you can imagine my state of mind and heart, especially after I had confirmed that no known comets other than Comet 2002-6 were in the area. I also checked all my star charts for deep sky objects in or near the suspect's position. Oddly enough, there were 2 galaxies, and he talks about those. Did I record it correctly? He looks at other things. I'm skipping. I had little to do but wait until the evening of January 22nd, 2003. That night, I brought my binoculars and my 4-inch telescope into the front yard, and under a crystal clear sky, I found Comet 2002, estimated its brightness. Next, I scanned for the strange object, and there it was exactly where I'd plotted it. Alas, it was not a comet, which would have moved by even a modest amount in 2 days, unless it was on a collision course with Earth. So I wondered, what is it? The telescope revealed the truth. My squashed comet is a lovely gathering of 9 8th to 11th magnitude suns in an area measuring a mere 15 arc minutes across. It's the little ladle. And so the story goes, on and on, hopefully into eternity. I encourage you to go out and find your own hidden treasure. Then he talks about several of these asterisms. And he says, this is not a cluster. It's just a little ladle. How about that? Well, we're going to save this object, even though it's just an asterism, and we're going to do the observation. I wonder if wind affected my scope out there. Can you see the stars, a little oblong? Stu, the paper napkin, staple of geniuses and inventors, right? We read the story by O'Meara that gave this asterism some, what would you call it, some character. Anyone can discover new asterisms, Stu says. Alas, like Stu always says, anyone can discover a new asterism. But it does indeed look like a ladle. So there you go. Stephen James O'Meara. We'll do another sort here. We'll change our sequencer to the next target. We've got 15 minutes left, and we can make it perhaps to X64, this planetary nebula. It's at 32 degrees above the horizon. And let's slew to it. It's X64 IC3568. IC3568. So what we do at this point in our screen, back in our imaging software, you see, we see some stars race across now and then. And those stars tell us that we're still slewing. See those little trails? They look like fireflies in the night. Once it settles, then we click this OK button. And that tells SharpCap it can now shoot the first image to see if we're indeed matched exactly with the night sky. It does this thing called plate solving. And you guys that have been with us before, you know how this works. It takes a picture through the telescope, it compares it to the pictures it has on file from star charts, it looks at the mesh between them, and if they don't match in the same place, it moves the telescope to match the expected position of the star charts. That way we're always making sure that we're right on track. Now we were 0.45 degrees off, which on this telescope, which has a field of view of about, I don't know, 2 degrees wide by maybe 1.5 high. It's a pretty wide field. You can see it would have been off a little bit. So it does that correction, and then it waits for 25 seconds for that correction to settle down in the scope. So the scope stops vibrating. And this sequence is mixed in with plate solving in SharpCap because the writer, the author, the developer of SharpCap gives us this ability to do both. We can do plate solving and we can write little sequences to automate things. And I love it now that all this is automated because we can be talking about or doing other things and SharpCap goes ahead and follows through with these functions. So now we're, I think, supposed to be right on track for this comet, this planetary nebula, sorry. I've got comet on my mind. Let's pull our black level down to about right there. And let's bring our reds down a little bit. Let's bring our mids down. And again, our reds down a little bit to compensate for this light pollution and moonlight. Now right there in the middle, we're trusting is our planetary nebula. It is tiny. But that's what we're getting here. And the hidden treasures is nondescript stuff that we would perhaps never have gone and looked at. I'm going to take just one more touch of red out of the picture. That is strange. That's either a companion star or something related to this planetary nebula. Let's look it up. This is X64, so we can quickly turn it to here in the book. Hidden Treasure 64, IC3568. By the way, we need to fix our little, this is X64. And it's IC3568, a planetary planetary nebula in Camelopardalis. Camelopardalis. A lot of little stories, a lot of history. IC3568 is considered one of the most circularly symmetric of all planetary nebulae. It is also one of the morphologically simplest planetaries in the sky. The nebula, which measures 0.3 light years across in true physical extent, was imaged in stunning clarity by the Hubble Space Telescope. It's a magnitude 12.3 central star that Hubble saw, surrounded by a bright inner sphere with smooth edges and a complex internal structure, namely a series of symmetrical linear features radiating outward from the central star. I wonder if we can see any of that structure by zooming in. First, let's review here. Let's go ahead and dial up our mids again. And let's now, no, we're starting to pixelate already at 200%. Look at that companion star. I wonder if that's just in the foreground, or is that truly there? It looks like a close 10th magnitude double star. The planetary, again, is the north one of the pair. That must be toward the top. IC3568 is extremely stellar at low power. If you believe you see fuzziness, it might be because the planetary and its neighboring star are so close together it gives the false impression of a halo of light. In other words, 3568 may look fuzzy at low power. And I'll show you the way he sketched it at low power as soon as I find it. There. That was his sketch at low power. So see, he's not even seeing the companion star like our RASA 11 is seeing using EAA, Electronically-assisted Astronomy. All he saw at low power visually was that halo. Mike says it's called the light bulb nebula. But that's an illusion if it looks like a halo. You really need magnification to see this planetary as a planetary. To confirm the planetary, he had to go to 101 power. At this power, it appears as a very obvious swollen star. It has an aqua tint. We're seeing that tint. It looks slightly bloated. At 182 power, some detail is suspected. Dim structure, perhaps shells. On a very steady night, which we don't have tonight, I think we're battling some wind out there. On a very steady night, he says he increased the magnification to 504 power, and he saw the planetary clearly with its very simple three-tier structure. Bright central star, bright inner halo, and diffuse outer halo. The inner halo measures roughly 10 arc seconds across. Small dimensions. It's easily passed over in a hasty sweep. Although it's very small, it has a high surface brightness. And then he talks about what it looks like in large telescopes. So X64 for us remains a bit elusive. I would say we'll do the observation here, but we haven't seen as much. The Line Nebula, the Lemon Slice Nebula, huh? Astigmatism Nebula. Light Bulb Nebula was Mike's idea. Ah, I can see it, Mike. Was that really your idea, Mike? Mike Fierberg called this the Light Bulb Nebula. That's the best name ever. Lemon Slice Stew or Lime Stew. Either way, it's bright but tiny. It was dubbed the Lemon Slice Nebula by Jim Kaler due to its appearance in one false color image from the Hubble Space Telescope. We couldn't make out much structure even after 8 minutes. Too tiny. Too tiny for our rich field RASA 11. But, you know, I see 3568. I see 3568. Look at that. Now you see why they call it the Lemon Slice Nebula. Wow. See that outer glow. And then this is the companion star that for us looks like the light bulb. Beautiful. All right, it's 10:57. We have just 3 minutes left. I think what we might do is quickly go to the Dark Shark, whatever that was called, Dark Shark Nebula. Right there it is, huh? Now what we can say here is we have to mark it again. Well, rats. Let's find it again. Dark Sharp Nebula, and then hit the, and then let's say current object slew, and we can also slew there directly in our planetarium software, Stellarium. The Baby Shark Nebula. So there you see the RASA. Oh, sorry. There you see the RASA approximating it, and you guys are singing a song I don't know. Now we're going to go back to the live view and stop live stacking. And we're going to call this the Dark Shark Nebula. And then down here, we'll just say Dark Shark Nebula. Don says, I'm lucky that I don't know the song. We're doing a quick plate solve just to make sure we're right on top of it. And this was Ricky who requested this. So Ricky, we're plate solving to make sure. And my goodness, we were 1 degree off. Why were we 1 degree off? I guess because we did a meridian flip, maybe. So now, after the plate solve, we should hopefully be in the middle of this thing. And thanks to those of you who have been with us tonight. We did make it through several objects in Stephen James O'Meara's list, but just looking at my my list over here, I think we can get another observing night before we kill off all the objects in this season. So very shortly we'll look for a. Did we really slew there? Because there's something in the middle that resembles that planetary nebula, huh? Are we really on it? Yeah, it shows that we're on it. Oh, look, there's that thing that resembles that planetary nebula we were just on. It's a close companion star. Okay, so we'll do one more color balance. Now we're going to bring our darks over to approximately where they should be, and then we're going to start bringing our mids up. Now at this point, I don't know if you can see it yet. At this point, I started seeing some darkness here and that patchiness that's behind it. Will this season end in a cliffhanger? Or does Don finally get a date? Ricky, you're lucky. Take his word for it. Oh, because of not knowing the song about the baby shark? If this is a hydrogen alpha region. It doesn't look like a hydrogen alpha region, does it? See, if it were hydrogen alpha, there'd be a lot more red in this. See, in my imagination, I can see some dark patches, but that just might be my imagination. We're at 3 minutes so far, so Ricky, I admit this is a challenge. What do we know about this? Let's go out to the web. And let's look up Dark Shark Nebula Wiki. Is it the Shark Nebula? Is that the same? The Dark Shark Nebula, LDN 1235, yeah. LDN 1235. So let's go over to, oh my goodness, isn't that fascinating? Oh my goodness, it does look like a shark. Look at that. That is just terrifying. Astrophoto.zoki from Croatia. Wonder how long he imaged this. He doesn't say. This could easily be like 8 hours of imaging. Oh my goodness, I'm scared just looking at this. I'm going to go over here in the observation software. I'm going to go to, first let's save this plan. I'm going to go to a different plan called Observe Next. And I'm going to say, oh, look, it was first on my list of observing next. What are the odds of that? And I'm going to say, add observation. This terrifying cloud of dust is a combination of dust and darkness. Don wants to know if there's a Japanese vessel behind it. As Ray says, that one takes a long time to image and do it justice. As Ray testified that it takes a long time to image and do it justice. Okay, let's go back to our real live, real-time image, and let's do another color balance. Now I'm wondering if some of that is real nebulosity. He's terrorizing us. It's nice there are a lot of different colored stars in the image. It is. You're right, Don. The Japanese vessel follows Cetus. The one has a Chinese boat behind it. Stu says. I tell you what, this does look like it might take a while. So, if you guys have to go, I would understand it. We're 7 minutes over. We'll say this concludes the normal Hidden Treasures video. We're stacking, so far, 7 minutes of integration on the Dark Shark Nebula. Imagine discovering that. That would be incredible. It must be those time exposure, like sky studies that they do, that our colleagues do with Schmidt astrocams. This is a Roe Ackerman Schmidt astrograph. But you know those Schmidt cameras that just capture the sky. Stu says, I'll watch as long as you stream. Don says, I think Koreans have the shark fin soup obsession. I'm likely wrong. So this wraps up the normal thing. You know what else would help us? Is to do this on a night when the moon is not at 50%. Let's also go back and figure out where we are in the sky. Is this the after show? That's right. So what we're going to do is we're going to back way off. And, oh no, is that the meridian? And are we on the, oh no, good. We're already on the west side of the meridian, I think. Good. Yes. So we must have gotten here right after. No, wait, that's probably our scope. So we are about to cross the meridian, sadly. See how our weights are east and the scope is bending over backward a little bit. So I wonder if I can pause when it starts to do its meridian flip, I wonder if I can pause the live stack. I doubt it, because we're going to have to do a plate solve when we go over to the other side. There's no way it's going to be perfectly synchronized. You know what else we could do? We could look up here, because I have it set to go 10 degrees past the meridian. And let's see. Oh, this says we're at 54. How can that be? Oh, it's 54 degrees above the horizon. But where do we see? I guess the fact that it's 359 degrees and 52 minutes. Yeah, that's what it is. 359 degrees and 51 minutes. Oh, do you think it already flipped? Yeah, I think we're okay then. Maybe? No, I bet that's, we haven't flipped yet. It's bending over backwards. So I think it'll let us get to 350 degrees before it flips, if I remember right. I think I have it set on a 10 degree margin, bending over backwards. Okay, so let's go back and check out our object. It's starting to look, there's more nebulosity here in the middle, isn't there? Let's zoom out so you can see what I mean. We're starting to make out the cloud now. It's represented in these funny red, so let's bring our reds down some. I'm keeping an eye on our scope there on the right side of the screen. Stu, it's going to be pretty boring after sunrise. Previews for the next episode. Stu, makes a change. We've been pointed at the horizon mostly lately. 3:59:40. We'll have some time yet. So look at that darkness here. Isn't that crazy? That is a dark patch of sky, isn't it? Let's dial this a little bit above. Bring down the greens. And then let's pull this over to here. Oh, I don't know. Let's find out what time the moon sets. Let's see, what's the easiest way to find that out? I think I'll leave this here and just go out to this and click to brace your eyes now, because this is going to look bright. We're going to go to clear outside. Moon sets at midnight, right? Yeah, 12 minutes after midnight. The moon is going to be a problem for another 45 minutes. Yeah, I have a flight that leaves early in the morning, so I'm not going to be able to stay all night, but let's see here. Man. It's funny the way those reds travel in lines, huh? The image I found, total exposure time, 8 hours, 40 minutes, 600 seconds per frame, 52 images. We have 14 minutes, perhaps. Maybe I should do another video dedicated to this and use guiding and longer exposures. Azray says, that sounds about right, Stu. And with live stacking, we could measure when we start seeing it, Ricky. So that way we know when it starts to show up. Maybe that's the best bet. Now, could this thing here, there's like a dark patch in there, could that be it forming up? Special episode, right. Yeah, see that darkness there. Oh no, that's just the eyeball, isn't it? Then this is cloudiness. And let's do that episode on a moonless night. Punch up the gain and auto stretch, okay? We're gonna raise the gain then to what? 300? Ricky says, this is so cool. You're nice. You're nice to encourage. Okay, now we're going to do an auto stretch. Look at the way the gain is moving the light curves over to the right. What a mess. What we're doing here is we're working with these vertical controls and the ever-changing white balance curves. We're trying to keep the black level, which represents the threshold of black. We're trying to keep it right around that crest. And you're just tuning it, looking for the object. And then these mids bring up the mid-tones, which are going to create the reverse for us. Zoom out as much, Azray says. Okay, that's full out. Ricky thinks he sees the mouth of the shark. You know, I think you're right, Ricky. It's right here, isn't it? And that's going to be the eye. "19 minutes, Ricky saw the mouth. Showing up near the top. You guys are fun. Who else would do this? We have 11 people that are hanging around to see if a shark shows up in this imaginary. This is like one of those deals you buy and you start washing it over with water to see if some magic message appears. The other thing we can do is we can go out here, and if we just play 5 seconds of it, we can try to hear the song about the baby shark. Baby shark song. Baby shark dance. Most viewed video. 118 views. Those people are fooling themselves. This one has 666 million views. But I'm telling you, we can only show 10 seconds of it. Ricky says, no! We can only do 10 seconds. Do you know why? Because after 10 seconds, our video will be marked off for copyright. So I'm going to set my stopwatch here. Reset. And who knows if we'll even get to start the song, because sometimes, you know, at the beginning, there's a little bit of an intro. So I'm going to click the song, I'm going to click in the middle of the curve, and then I'm going to start my stopwatch all in one motion. Ready? Okay, I'm going to have to stop Stellardrome. Okay, we stopped it. I think that qualifies because we were just right under 15 seconds. And now I've heard a segment of the song. Doot, 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 baby shark, doot, 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 doot. Stu says, I'm going to turn it off. Don says, don't do it. Mike says, yes. Ricky says, no. Azray says, well, there is no shark in Arizona. Well done, Ricky. Okay, now back to the live view. Let's let's put our music, our non-copyrighted song back on. And boy, these curves are actually playing a little better now for some reason. I don't know why. Maybe the moon is setting lower. You guys are wild. Only you guys can convince me to stay later and use my sleep time. Look at that. Isn't that crazy? Ricky says, I'm in South Florida. Well, Ricky, did you survive Ian okay? My goodness. You must be on the East Coast. Or else maybe you still wouldn't have electricity. Aren't they swimming in the streets right now? Stu, at least 3 Floridians here tonight. That's right. Well, we're at 23 minutes, and now you can definitely see the way this is going to shape up. that dark nebula, the dark shark nebula, the eyes are going to be right here. And the mouth is going to be right here. And this shark is going down into the water. Oh my goodness. Here are you guys back again. Always listen to signs, Dark Meta says. Fort Lauderdale, a lot of tornadoes from the outer bands. No real hurricane force winds. Dark Meta, Ian damaged me here, but only 50 mile an hour with 60 gusts. Yikes. Like the sound effects, right? Okay, boy, I tell you what, these new images, as Ray suggested, really did help, Azray. When you said go to a higher gain, we went to 300. But every new image that comes in is brightening up the light curve. That star cluster is a seal near its mouth. Who would have imagined that in 25 minutes we're already seeing this sky? Terrifyingly so. .357. Boy, if our scope, it does look like it's bending over backward. It's at 357.47, so we have about 2 degrees and 46 arc minutes before it shifts, and that's when we'll call this. This terrifying cloud of dust, a combination of dust and dark, Azra's testified that it takes a long time to image and do it justice. We started seeing the shark image at 18 minutes, but just the shadow. At 25 minutes, it was much clearer. Okay, back to the live screen. Our colors are staying in balance now a lot better. You know, I wonder if we could increase the exposures to 30 seconds. Dark Meta, a huge tree branch broke off about 100 feet from where I sleep, and I'm kind of glad because that would have been fatal. Ah, yikes. Big 50-foot oak branch, 1.5 feet wide. Azra, it doesn't hurt to try higher gains on some objects. Dark Meta, about the length of 4 vans. Yikes, done. Good thing you're not a squirrel, you'd be flying squirrel. Azra, fast optics help for sure. Ricky, Dark Meta, where the wind's constant? Stu, you Americans will use anything to measure except the metric system. 4 SUVs long. Azra, astrophotography, on scope cam. Oops, sorry. Only things covered. That's 126 packs, thank you. Okay, so let's back these mids off. Boy, when that thing flips, we're at 357. I don't understand that. I don't think I could do 60 seconds. Azray suggested we go to 60. The gusts were scary. Yeah, without guiding, I don't think I could do 60 seconds, but I could probably hook up. No, my guide scope is actually has this lens cap on. It's out there. I usually don't even fool with guiding, but you know, it would help on this object to do guiding and do a longer exposure perhaps, but 28 minutes. I wonder if that 30 seconds overexposed. Do we have, oh, I see. The rest of this nebula is going to show up as a little bit brighter, isn't it, in the image? And that's what the rest of this is. Guys, we're talking about the hurricane impact there. Yes, we could dither. You're right. Yeah, I just usually haven't needed this much time. I think the longest we've ever needed is 7 minutes to do anything. But this is a challenging object, isn't it? This is a faint object. Wonder if the messing with the color bands would help some. Maybe try pulling the reds down a little bit. No, that turned that green out there. Wonder if we could bring up these lights a little bit. This is definitely daddy shark. Do-do-do-do. You guys are wild. Only you guys would hang around to do this. on a 50% moonlit night. Push the reds and lower blues and greens. Okay. Boy, since we've seen pictures of it before, we kind of know what to look for. Look at the dark nebula there. How it drops out. That's cool, isn't it? A dual band filter would also help against the sky glow. Ghostly. Ghostly glow at 28 minutes. You know, we have some light pollution here too. Not to complain, but yes. Boy, one click. Stu. Well, guys, you can see the shape coming together there now, can't you? That's at 28:40. I think we'll call it at 30 minutes. And we'll try this again on a moonless night. I think that'll help us with these faint objects. I remember once doing, trying to visualize using EAA another really faint nebula, and I don't remember which one it was. Could have been the Heart Nebula, maybe, I can't remember, or one of those. And I remember trying it again then on a moonless night, and it just made a big difference. So I think this is enough that you can get an idea. Let's just save this as seen and call it. But honestly, you guys are great to be good sports and try this. We are gonna do a live stream whenever we can, like once a week or sometimes twice a week, whenever there are clear nights. We'll make sure we always put an announcement in the YouTube channel, usually 24 hours in advance, sometimes 48. So it would really help if you'd subscribe if you haven't already done so. We also have an email list. We email at least 24 to 48 hours out, and you can subscribe to that by going to emeraldhillskies.com. Also at emeraldhillskies.com, you can go to the resources tab and look at the 3 lists that we're following. The Caldwell list, the Herschel 400, and the one we've been working on tonight, the Hidden Treasures, Stephen James O'Meara's Hidden Treasures list. And because the way the seasons allow you to see different parts of the night sky up there, we're kind of hitting parts of all 3 lists as we go through the year. And you can follow our progress and see which ones we haven't imaged yet and how many we have left to go. So I'll be taking the ones that we observed tonight and updating the Hidden Treasures list there. It helps if you subscribe at YouTube. It helps if you click thumbs up if you like this. If you didn't like it, put thumbs down. But it helps if you put thumbs up because it elevates the channel in other people's searches. And when you subscribe, it does the same thing. Thanks for being a part of this. I have to say thanks to God for making all these incredible features of the night sky for us to look at. I just would have never believed that these things were up there all along. And I hope you'll stop back by. Thanks to you guys who are here for the kind things you say to encourage. Let's see. Don says, Azray, thanks for sticking with it, Doug. Don says, thanks for doing it, worth a shot. Ricky says, thanks so much for doing this. Mike says, thank you. Stu says, thanks. Another great night full of wonder and learning. You're great, Stu, to encourage. We're going to continue to hide these intruders that are here and hope that over time they get tired of bothering us. Don says, last chance for a couple of dates, guys. Don says, good night, good morning all. And Ghost Boat, great watching that shark come into view. Good night, bless. God bless, good night.